Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have set our hearts to solve a paper 2. We call it theory paper. And for this purpose, we have selected May-June 2023 2 paper. The time allowed for this paper is 1 hour 45 minutes, and the total marks for this paper are um, 80 marks. So let's start today's paper, and here we go. So this is the paper, and let me reduce this size. In this video, I'm going to present to you the solution of this paper. The very important thing is that in this paper, the value of the small g acceleration due to the free fall or the gravitational field strength on the earth is taken as 9.8 meter per second, or you can say 9.8 Newton per kg. The total marks for this paper are 80. The time allowed is 1 hour 45 minutes. So let's start. The question number 1 is showing up on your screen. So we have question number 1. Figure 1.1 shows the speed time graph for a car traveling on a straight horizontal road. So this is a speed time graph. On the y-axis, the speed is represented, and on the x-axis, the time is represented. And you can see that in the first 10 seconds, the speed is constant. And that speed is how much? It is 18 meter per second. After the 10 second, from 10 second to 50 second, the speed of the car is decreasing. It's decelerating. And it's decelerating, and the graph is a curve, which means that it's decelerating non-uniformly. And in from 10 to 50 seconds, from time 10 seconds to time 50 seconds, the car decelerates from 18 meter per second to 2.5 meter per second. So this is the speed time graph given. He says describe the motion of the car shown in the figure 1.1. So I have already explained to you the, okay, so here we go. From t 0 second to t 10 seconds, the speed of the car is constant, and that constant speed is 18 meter per second. From t equals to 10 second to t equals to 50 second, the speed decreases non-uniformly from speed 10 meter per second to speed 2.5 meter per second. I hope you understand. And here we have this. Okay, so this is my answer. So we're going to the next part. Question number 1, it's B part. He says at the time 10 seconds, the engine of the car is switched off. The brakes are not applied. Name 2 forces that act on the car to cause the change in motion after the 10 seconds. So when you have switch off the engine, so what will happen? There will be 2 forces acting on the car. One is the air resistance, because the car is moving, so the air resistance is acting on it. So one force is air resistance. The second force is the friction between the tires and the road. So question number 1B, first part, air resistance and the friction between the tires and the road. So you can see the marking scheme, and this is my answer, and here we go. So question number 1B, second part, he says, suggest why the figure 1.1 is a curve after t is equals to 10 seconds. So their question is, here you have switched off the engine, and now the 2 forces which are acting on the car are the air resistance and the friction between the tires and the road. And the deceleration is non-uniform. This means that the resultant force acting on the car is gradually decreasing. How do I know that gradually decreasing? Because the gradient of this curve is gradually decreasing, which means that the deceleration at the start was more, and the deceleration after some time has, or you can say deceleration is gradually decreasing. That means that the resultant force acting on the car is gradually decreasing. Gradient of the speed time graph represents acceleration, or you can say deceleration. Deceleration of the body is gradually decreasing. That means that the resultant force acting on the car is gradually decreasing. This is my answer. Or you see, when you slow down, the air resistance acting on you decreases. So Question number 1 is C part. He says between time 10 second to time 20 second, the speed of the car changes from 18 meter per second to 11 meter per second. The mass of the car is 1200 kg. Calculate the change in the momentum of the car in this time. Give the unit of your answer. So the change in the momentum is the final momentum minus the initial momentum. And you know the momentum is the product of the mass and the velocity. So here we go. The change in the momentum will be mv1 minus mu1. So the mass of the car is 1200 kg, and initially its velocity was 18 and the final velocity was 11. So 1200 multiply 11 minus 1200 multiply 18, and that will be 8400. The units can be kg meter per second or it can be Newton second. Both are the unit for the momentum. Change in momentum can be Newton second or it can be kg meter per second. This is my solution. I hope you understand this numerical. Okay, so then we have the question number 1C and its second part. He says calculate the average resultant force exerted on the car during this time. You know the average resultant force, the formula, you remember the formula for the resultant force can be F is equals to ma, or there is another formula for finding the resultant force, and that formula is that the resultant force is equals to the rate of change of momentum. It means change of momentum, change in the momentum divided by the time. So we are going to use this formula, the change in the momentum divided by time. So F will be equals to the change in momentum divided by time. Change in momentum is 8400 kg meter per second, and the time taken for this change is from 10 to 20 seconds. That means 10 seconds has been taken for this change. So 8400 divided by 10, that will be 840 Newton. So the resultant force is 840 Newton. 840 Newton. 840 Newton is the right answer. This is the solution. So we are going to the next question. The next question is question number 2. Figure 2.2 shows a rider on an electric scooter. So here we have an electric scooter. The scooter contains a battery and a motor to drive the back wheel. State the name of the energy stored in the battery. You know, in the battery, in the food, in the fuels, the energy stored is the chemical potential energy. So we will write here and the chemical potential energy. Chemical potential energy. So you can look at the marking scheme. This is my answer. Okay, so here we go. He says question number 2A, second part. He says describe in terms of work done the stages of the energy transfer from the energy stored in the battery to the kinetic energy of the scooter. You see the energy which is stored in the battery is chemical potential energy, and the battery converts that into the electric energy, and that is being done inside the battery. Then the electric energy is provided to the electric motor, and that electric motor converts the electric energy into the mechanical energy, and that mechanical energy is then converted into the kinetic energy of that scooter. So this is my idea. Let me show you my answer. In battery, chemical potential energy convert into electric energy. In motor, electric energy is converted into mechanical energy. So the electric scooter moves and has kinetic energy. Some energy is also converted into heat to overcome the friction between the tires and the road. This is my answer. So here we have electric current or electrons made to move. Mechanical work is done by the motor or by the back wheel. So this is your answer. I hope you can write a better answer. I just give you an idea how to write an answer. Okay, question number 2, and it's a B part. He says the total mass of the scooter and the rider is 70 kg. Calculate the total kinetic energy of the rider and the scooter when the scooter has a speed of 4 meter per second. So the mass of the scooter and the rider is given, that's 70 kg, and their speed is also given, that is 4 meter per second, and they are asking us to find out the kinetic energy. The formula for the kinetic energy is 1 by 2 mv square. Simply just substitute the value of the mass and the velocity there, and you will be able to find out the kinetic energy. So the kinetic energy is equals to 1 by 2 mv square, 1 by 2 multiply 70, multiply 4 square, and your answer will be 560 joules. 560 joules is the right answer, sir. 560 joules is the right answer. So this is the solution. Okay, so question number 2 and its C part. The battery is marked the battery is marked energy capacity 0.35 kilowatt hour. Define what is meant by kilowatt hour. Kilowatt hour is basically the unit of energy. So that means, what does that mean? It's the unit of energy, and it means that if we have some machine whose power is 1 kilowatt and it work for 1 hour, or you can say if a power of 1 kilowatt is being provided for 1 hour, the work done or the energy transferred will be 1 kilowatt hour. So this is my here you can see energy transferred at a rate of 1 kilowatt in 1 hour is 1 kilowatt hour. So this is the solution. You can see the marking scheme. Okay, so this is what I have written. Okay, then we have the question number 2C, second part. He said the scooter stops working because the battery is totally discharged. This means that there is no more energy stored in the battery. The battery is then recharged using a 70-watt power supply. Calculate the time taken to fully recharge the battery. So we know the uh, you know that we know that power, and we know the energy stored, and their question is how much time it will take. It's a 2 marks question and very simple. The power is equal to the energy divided by time, and the time will be equals to the power is equals to energy divided by time. So the time will be equals to energy divided by power. The energy is 0.35 kilowatt hour, and the power, I will convert this is also into the kilowatts, and it is 0.070 kilowatts. So you divide the energy with the power, so you will get 5 hours. So the time taken will be 5 hours. 5 hours. 5 hours is the right answer, sir. We have converted the given power also into kilowatts because the energy used here is in kilowatt hours. Okay, so here we go. Question number 3, and this is the solution of that part. Okay, question number 3. He says a fixed mass of gas in a glass tube is trapped by a seal at one end of the tube and by a column of mercury. The mercury is free to move within the tube. The tube is rotated slowly from the vertical as shown in the figure 3.1 to the horizontal as shown in the figure 3.2. The volume of the gas increases and its temperature remains constant. So we are talking about a gas, its temperature is constant. This sentence is very important. This sentence is important. The temperature is constant. So whenever the temperature is constant, the pressure and the volume, they are inversely proportional to each other. Okay, so their question is when the tube is, this end is open, this end is sealed, here we have mercury, here we have gas. Now the tube is horizontal, here we have the mercury, here we have the gas. You can see the volume of the gas has increased. Describe why rotating the tube changes the pressure of the gas in the sealed end. You see, when the tube is like this in the vertical position, the the depth of the mercury above the gas due to the weight of the mercury causes the pressure, and plus it has atmospheric pressure acting on it. When you make the tube like this horizontal, the weight of the mercury is no more acting on this gas. So the pressure of the gas will decrease. Describe why rotating the tube changes the pressure of the gas in the sealed end. So I hope you understand. In vertical position, the weight of the mercury is acting on the trapped gas, so the volume of the gas is smaller. So it has higher pressure. In horizontal position, gas is under the weight. It is not, sorry, here I forgot to write not, is not under the weight of mercury. It means the weight of the mercury when that is horizontal, the tube is horizontal, is not acting on the gas. Volume of the trapped gas has increased, so its pressure has decreased. So this is my idea. Mercury exerts a changing or reduces reduced pressure force when vertical, but when horizontal, mercury stops exerting a pressure. So I hope you understand. The weight of the mercury is no more acting on the gas because when the tube is horizontal, so the pressure of the mercury is no more acting on that gas. So the pressure of the gas will decrease. Okay, question number 3A and its second part. Explain using ideas about the particles why the pressure of the gas decreases when its volume increases. You see, when the volume of the gas increases and the temperature of the gas remains constant, the number of the gas particles per unit volume decreases. The collision frequency of the gas molecules with the walls of the container or the tube decreases, and less number of the molecules now collide per unit volume so that's why less amount of the force is exerted per unit area. So that's why the pressure of the gas decreases. So this is my point of view. Okay, let me show you what I have written. When the volume of gas increases, the temperature is constant. Pressure of the gas will decrease. This is because number of gas molecules per unit volume decreases. Collision frequency of gas molecules with, this word is with walls of container decreases. So the force exerted per unit area decreases by the gas. The force exerted by the gas per unit area decreases. Okay. So this is the answer. I hope you can read it. This is my written answer. So we are going to the next part. Question number 3 and its B part. He says in the figure 3.1, the length of the mercury column is 0.30 meter. The density of the mercury is 14,000 kg per meter cube. Atmospheric pressure is 1.0 expo 5 Pascal. Calculate the pressure of the gas in the tube. So they are talking about the figure 3.1, and in the figure 3.1, we have atmospheric pressure acting on this gas plus the pressure caused by this mercury. And we can calculate the pressure caused by the mercury. The formula is very simple, rho GH. So I will calculate the pressure caused by the mercury and the pressure caused by the. So first of all, I will calculate the pressure caused by the mercury, and then in it I will add the atmospheric pressure, and that will be the total pressure which is acting on the gas. So the pressure caused by the mercury is rho GH. Rho GH. Rho means the density of the mercury, G means the gravitational field strength, and H means the depth of the mercury column. So the density is 14,000 kg per meter cube. The G value is 9.8 Newton per kg, and the H value is 0.30 meter. Just put those values, you will get 41,000 Pascal. Now, the total pressure acting on the gas will be the pressure due to the mercury plus the pressure due to the atmosphere. So we will add both these pressures. So 41,000 plus 1 expo 5 Pascal, and you will get 141,000, 141,000 Pascal. 141,000 Pascal, they have rounded it off and they have written it as 140,000 Pascal. 140,000 Pascal, you can round it off because here I have written three significant figures. So it is approximately 140,000 I'm writing with the mouse, is quite difficult. So Pascal, okay. So this is our answer. I hope you understand. C part, the pressure of a different sample of a gas changes at constant temperature. Figure 3.3 shows 1 point marked X on a graph of pressure against volume of the gas sample. At X, the pressure of the gas is P naught and its volume is V naught. Okay. So what is their question? On the figure 3.3, sketch the graph as the pressure of the gas decreases from the 2 P naught to half the P naught. Okay, so when the volume will become double, when the volume will become double, the pressure of the gas will become half. So this is the point. And if the volume will become half, the pressure will become double. So this is the point, and then I will join them with a curve. Let me show you I have done this. So hopefully this is showing up on your screen. And you can see I have put this dot, and then I have joined them with a smooth curve. And I hope that you can see this is the marking scheme and our answer is right. Okay, so this is the graph which you have to draw. So that was question number 3. Now we are going to the next question, and that is question number 4. He says the figure 4.1 shows the particles, atoms at one instant in a sample of iron at a temperature below its melting point. Question number 4a, first part, state the lowest possible temperature on the Celsius scale and on the Kelvin scale. In the Celsius scale, the lowest temperature is minus 273 degrees centigrade, and in the Kelvin scale, we call it absolute zero. We call it 0 Kelvin. So in these fill in the blanks, we will write minus 273 and 0 Kelvin. You can look at the marking scheme. This is my answer, 0 Kelvin. Okay, question number 4, and it's A and second part. The temperature of the solid increases. The sample remains a solid. Describe how the motion of the particles change. You see, when you will provide, heat to solid, what will happen? Its particles will start vibrating vigorously. The amplitude of their vibration will increase. Their kinetic energy will increase, but they will remain in their fixed positions. The amplitude of vibration will increase, and the distance between the particles will increase. Okay, so the particles start vibrating. The particles start vibrating vigorously. Their amplitude of vibration will increase. The distance between the particles will increase. Their kinetic energy will also increase. The particles move faster, vibrate, oscillate with the larger amplitude. So I hope you understand. This is my answer. So we are going to the next part. He says question number 4a, third part. The solid melts. State what happens to the internal energy and the temperature of the solid as it melts. So when something is melting, the internal energy increases, but the temperature of that thing remains constant. So for internal energy, we will say that will increase because its potential energy will be increasing, but the temperature remains constant during that melting process. So the internal energy decreases, the temperature stays the same. This is the answer. This is question number 4, and it's B part. He says a student places a 300-gram piece of iron in the boiling water until the iron is at a temperature of 100 degrees centigrade. Removes the iron from the water and places it immediately into 100 gram of water at 25 degrees centigrade. The iron cools and the water warms until both reach the same temperature, which is 44 degrees centigrade. The specific heat capacity of the water is 4.2 joules per gram per degree centigrade. No energy is lost to the surrounding. Calculate the change in the internal energy of the water as it warms up. You see, so the water whose mass is 100 gram and its initial temperature was 25 degrees centigrade, and when you put a hot piece of iron in it, whose mass is also 300 gram, the temperature of that water rises and the temperature becomes 44 degrees centigrade. So the specific heat capacity of the water is given. This is a case of increase in the temperature. So whenever there is an increase in the temperature, the formula we use to calculate the heat is equals to mc delta theta. mc delta theta. So where the m stands for the mass and the c stands for the specific heat capacity and the delta theta means the change in the temperature. So we will have 100 grams multiply 4.2 joules per gram per degree centigrade and multiply change in the temperature 44 minus 25, that will be 19 degree. So the change in the temperature is of 19 degree. For the water we are doing this calculation. So multiply 100 with the 4.2 and with the 19, you will get 7980 joule, which is approximately 8,000 joules. 8,000 joule is the right answer, sir. This is the solution. And here we go. Then he says calculate the specific heat capacity of the iron. You see, try to understand this, that you have a hot piece of iron. You put it in water which was at lower temperature. And so what will happen? The iron will lose heat and the water will take the heat. So the heat lost by the iron will be equal to the heat gained by the water. In the first part, we have calculated how much heat is gained by the water. So the heat lost by the iron is equal to the heat gained by the water. And for iron, I can write the heat lost is mc delta theta. That means the mass of the iron. C means the specific heat capacity of the iron. And delta theta means the change in the temperature of the iron. The temperature of the iron changed from the iron was at 100 degrees centigrade and at the end the temperature of the iron was 44. So the change in the temperature for the iron is 100 minus 44 and that is 56. So there is a change of 56 degrees in the temperature of the iron. So 300 multiply C multiply 56 is equals to the heat gained by the water. In the first part we calculated is 8,000 joules, and then the C will be equals to 8,000 divided by 300 divided by 56, and that will be 0.47 joule per gram per degree centigrade. 0.48 joules per gram per degree centigrade is the right answer, sir. Question number 5, he says water waves are transverse waves. Underline two other examples of the transverse wave. You know, the secondary waves, the seismic S waves, the secondary waves, they are transverse waves. And the X-rays are electromagnetic waves. All the electromagnetic waves are transverse waves. Okay, then he says the figure 5.1 shows a wooden bar and a glass block in a ripple tank. The depth of the water in the ripple tank is less than the height of the glass block. Okay, so then they say, so this is a proper barrier for the water waves. And you know, whenever the water waves will pass, wherever you have a barrier and there is some path for the water waves to go forward, so at this corner, their diffraction will take place. The wooden bar moves up and down once every 0.15 second to create the crust. So this is the time period given for one wave. The speed of the water wave is 27 centimeter per second. Calculate the frequency of the and the wavelength of the wave. If you know the time period, you can calculate the frequency. You know the time period must be in seconds, and then the frequency will be 1 by t. Reciprocal of the time period, if the time period is taken in seconds, is so the time period is 0.15 seconds. So the frequency will be 1 by t. So 1 divided by 0.15, and that will be 6.67 hertz. So the frequency is 6.67 hertz. Use the equation of wave equation, which says V is equals to F lambda. Here the lambda means the wavelength, and that is question. The speed of the wave is 27 centimeter per second, and the frequency is 6.67 hertz, and the lambda is the question. So the lambda will be 27 divided by 6.67, that is 4 centimeter. So 4 centimeter is the wavelength. 4 centimeter is the wavelength. You can look at the marking scheme. I hope you understand. This is my solution. Okay, then the question is, this is the second part of question number 5. He says the wave diffracts at the right angle, right hand edge of the glass block. So on the figure 5.1, draw two crusts after they pass the glass block to show the diffraction. So the 2 marks question. So let me show you. So when here they pass through by a hindrance or by a barrier or by an obstacle, so what happens? The waves will bend. The waves will bend at the corner, and this is called diffraction. So here you can see I have shown diffraction, and the wavelength do not change. The wavelength remains the same. So that's why you can see the wavelength is still the same. But when the wave passes from here, I have made this end of the wave fronts circular. This is diffraction. I hope you understand. So our answer is right, sir. This is how you will draw this. So hopefully you understand how to draw this, and here they have converted into circular wavefronts. The reason is the diffraction. He says, describe how a wave with a smaller wavelength is made with the wooden bar. So if you want to make the wooden bar is vibrating, it's moving up and down, up and this oscillatory motion of the wooden bar is producing the water waves in the ripple tank. So if you want the smaller wavelength, then the frequency of the wooden bar, the vibration of the wooden bar or the oscillatory motion of the wooden bar, its frequency should increase. If the frequency will increase, automatically what will happen? To make a smaller wavelengths, to make smaller wavelengths, increase the frequency of the vibration up-down motion of wooden bar. This is our solution. Okay, so this answer is here. So our answer is right. Okay, so we are going to the next part. That is the fourth part. He says, describe how, oh, we are done with it. No, fourth part is describe how a decrease in the wavelength affects the diffraction. The smaller the wavelength, the less will be the diffraction. So there will be less diffraction when the wavelength of the water waves decreases. You know the gap there from where the waves are passing. If that gap is of larger size, more than the size of the wavefront, wavelength, sorry, then less diffraction will take place. So less bending, less diffraction. Okay, so question number 6, we are talking about figure 6.1 shows an electric circuit containing a filament lamp, a resistor, a 12-volt battery, and 5 meters. So here you have ammeter 1, ammeter number 3, ammeter number 3. Here you have ammeter number 2. Here you have voltmeter 1, and here you have voltmeter number 2. So here is a lamp, here is a resistor. V1 is noting down the voltage across the filament lamp, and V2 is telling you the voltage across the resistor. Ammeter 1, ammeter 2, ammeter 3, they all are noting down the current because they all are connected in series. There is only one path for the current, so all of them will be showing the same amount of the current. He says the reading on the ammeter 1 is 0.25 ampere. The reading on the voltmeter 1 is 3 volt. Determine the reading on the other meters. So because the current is 0.25 ampere here, so same current will be here, same current will be here. So the A2 reading will be also 0.25 ampere. The A3 reading will be also 0.25 ampere. The EMF of the battery is 12 volt. So the 3 volt is being used here. So out of 12, 3 volts are used here. So the V2 will be showing 12 minus 3, and that will be, I think, 9 volt. So this is how you will do this. And 0.25 ampere, 0.25 ampere, and the 9 volt. I hope you understand this. So question number 6, A part. Okay. Then their question is calculate the resistance of the wire R. So if I know the voltage drop here, so if I know the voltage drop here and if I know the amount of current flowing from here, I can tell you how much is the resistance of the R. It's very simple. You know, V is equals to IR, Ohm's law, and R will be equals to V divided by I. The R it will be equals to, on that fixed resistor, the voltage drop is 9 volt and the current flowing through it is 0.25 ampere. So divide the 9 with the 0.25, you get 36 ohm. So the resistance value R will be of the fixed is 36 ohm, and the answer is right. This is my solution. Okay. So now we are going to the question number 6, A part, and its third portion. The resistors obeys Ohm's law. He says state Ohm's law. Ohm's law says that the current through the voltage drop across a resistor is directly proportional to the current flowing through the resistor. You can, instead of using the word resistor, you can use the word conductor also. So I can say the voltage drop across a conductor is directly proportional to the current flowing through the conductor, provided that the physical conditions of the conductor do not change. So here we go. He says that the voltage drop across a resistor is directly proportional to the current flowing through it, provided the physical conditions of the resistor do not change. So this is the statement of that Ohm's law. Instead of saying the physical condition, you can say the temperature of the do not change. So here we have figure, then we have question number 6 and its B part. He says, figure 6.2 shows the current voltage graph of the filament lamp. So here you have the current showing and here you have the voltage across the filament lamp. So they are talking about basically this filament lamp. So they say that okay. So their question is the battery in the figure 6.1 is replaced with a different battery which has a different EMF, electromotive force. The voltage across the lamp increases to 6 volt. Now the V1 reading here is 6 volt. So, and he says that the voltage across the lamp increases to 6 volt using the data from the graph to determine the EMF of, use the data from the graph to determine the EMF of the second battery. Show your working. Okay. So the voltage drop across the filament lamp is 6 volt. So this is that number. From here, I will go to the graph and I will check what is the reading here. So this reading is approximately 0.35 ampere. So the current flowing through that filament lamp is 0.35 ampere. How do I know? I know from this figure 6.2. So once I know that the current flowing through the you know that filament lamp, that is 0.35 ampere, so same amount of the current will be flowing through that and the other resistor, so fixed resistor. And we know the resistance of that fixed resistor we calculated in the previous part. So if I know the current flowing through that fixed resistor and I know its resistance, I can calculate the voltage drop across that fixed resistor. So the I there is 0.35 ampere and the V2 value will be I multiply R. I know the current flowing through the second and that fixed resistor, and I know the resistance also 36 ohm. Just multiply, then you will get 12.6 volt. So the total voltage of the battery, which we call EMF of the battery, that will be the voltage drop on the lamp plus the voltage drop on that fixed resistor. So V1 plus V2, and that will be 6 plus 18.6, that is 18.6 volt. So when I will round it off to two significant figures, it will be 19 volt. 19 volt is the right answer, sir. This is my solution. This answer of the current for the filament lamp we got from that figure, that graph which was given. Okay, so we are going to the next question, and that is question number 7. He says ultraviolet radiation is one component of the electromagnetic spectrum. Question number 7A, first part. State the name of the two components of the electromagnetic spectrum that have a smaller wavelength than the ultraviolet radiation. You know, the code word for that electromagnetic spectrum is Ronald McDonald is very ugly except Gary. Radio waves, microwaves, infrared, visible light, ultraviolet, X rays, gamma rays. So, in this pattern, when you go down, your wavelength decreases. So, they are talking about the ultraviolet. So, the waves whose wavelength is less than, who have the smaller wavelength than the ultraviolet, are X rays and gamma rays. So this is my answer, sir. Okay, question number 7 and the second part, he says, state one useful application of the ultraviolet radiation. The UV light, the ultraviolet radiation is used in for tanning purposes in the sunbed. So UV is used in the sunbed. So there are so many uses. For tanning purpose in the sunbeds. Okay. There are so many uses. You can write any one of them. Question number 7A, third part. He says, exposure to the ultraviolet radiation from the sun damages the eyes. State one type of damage to the eye caused by the ultraviolet radiation. So when your exposure to the UV light or to the direct sunlight increases, so you see there are some damages to the eye. For example, it can cause cancer, it can cause cataract. Cataract is motia, and it can destroy your cornea, it can destroy your retina. So these are the some damages. We think that it can destroy the retina, it can cause a cataract. So cataract is motia. Skin cancer, cataracts, burns, or destroys the retina or cornea. Okay, so hopefully this is a simple, straightforward question. He says the next question coming up on your screen is question number 7, is B part. He says the figure 7.1 shows a ray of light. The ray passes into a semicircular glass block at A and leaves the glass at B, traveling along the surface to C. State the name given to the angle of incidence marked at 40 degrees centigrade. You see, this angle of incidence is in the dense medium. Light is entering from the dense medium into the rare medium. The light is entering from the glass into the air. The angle of incidence is such that its corresponding angle of refraction is of 90 degree. So that angle of incidence in the dense medium for whose corresponding angle of refraction in the rare medium is of 90 degree is called critical angle. So the name of that angle is critical angle. Its name is critical angle. So I hope you understand. Then he says calculate the refractive index of the glass. The refractive index of the glass and the critical angle has a relationship. So the refractive index is represented with the N and the critical angle is represented with the C. And the formula is N is equals to 1 divided by C. 1 divided by sine C, sorry. N is equals to 1 divided by sine C. It's a famous formula, and you must have seen it many times. So N is equals to 1 by sine of 40, and that will be 1.555, which is, when you round it off to two significant figures, it will be 1.6. 1.6 is the refractive index. So this is how you do question number 7. We are going to the next question, that is question number 8. He says that the figure 8.1 shows a step-down transformer used to operate an electric bell. So they are talking about a transformer. Here we have iron core. That frame is made of iron, soft iron. And here on this side, we have the primary coil. You give a voltage to the primary coil. And here we have the secondary coil. In the secondary coil, the voltage of the EMF is automatically induced. This is a step down transformer. Why? Because the number of turns on the secondary coil are less, and the number of the turns on the primary coil are more. He says, state the A part, state the material used for the core of the transformer. This core of the transformer is all the time made from the soft iron. The core of the transformer is made from the soft iron. I hope you understand. So then we have next part, B part, question number 8. A current in the primary coil produces a magnetic field in the core. Explain how an alternating voltage is produced in the secondary coil. You see, if you will provide in the primary coil an alternating current, if you provide alternating current in the primary coil, here on the primary coil an electromagnet will be formed. And because you have provided here the alternating current, so the polarity of this electromagnetic will be periodically changing. Sometimes you will have north here and south here, and sometimes you will have north here and south here. So the polarity of this electromagnet formed on that primary coil will be periodically changing. Obviously, the magnitude of that magnet is also, the strength of that magnet is also periodically changing. So its magnetic lines through this iron core are passing through this secondary coil. And these magnetic lines are periodically changing their magnitude and their direction. So the magnetic flux of this electromagnet is passing through this secondary coil, and it is changing in direction, and it is also changing in magnitude. Due to the changing magnetic flux, EMF is induced in the secondary coil. This is Faraday's law. And because the direction of that flux which is passing through that secondary coil is also changing, so the direction of the EMF induced in the secondary coil is also changing. So this is how alternating current is induced in the secondary coil. Let me show you my written answer. Electromagnet formed on primary coil is periodically changing its polarity and magnitude. And this is because you will provide alternating current to the primary coil. The magnetic lines of this electromagnet are here you should have written are passing. They are passing. Sorry, I forgot this word. I missed that word. They are passing from the secondary coil through the iron core. Due to changing magnetic flux, EMF is induced in the secondary coil. Alternating EMF is induced in the secondary coil because direction of the magnetic lines passing through it is changing periodically. So hopefully you understand. Let me reduce the size so you can see the whole answer. So this is, we think, what is the reason. So input voltage or input current is alternate. This is very important. I have not written there, but you should write there that the primary coil is connected with the alternating current. I described this thing, but when I wrote, I did not wrote that. So the current you provided to the primary coil, that must be alternating, and the rest is in front of you. You can take your time, read this marking scheme. That answer is here, 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 here. Stop the video, pause the video, I mean. And this is my written answer, and here we go. Question number 8 and its C part. He says a transformer has 4600 turns on the primary coil, which is connected to a main supply of 230 volt. And output of 5 volt is used to operate the bell. Calculate the number of the turns needed on the secondary coil. So, you know, the very simple numerical on the transformer, and it's a famous numerical. The number of turns on the primary are 4600. The number voltage in the primary is 230 volt. The voltage in the secondary is 5 volt. Number of turns on the secondary is question. Very famous equation that the number of turns on the secondary divided by the number of turns in the primary is equal to the voltage in the secondary divided by the voltage in the primary. So the number of turns on the secondary is question. The number of turns in the primary is 4600. Voltage in the secondary is 5. Voltage in the primary is 230. So the number of turns in the secondary will be equals to 5 multiply 4600 divided by 230, and the answer will be 100. So 100 turns, and you can see the marking scheme. Our answer is right. This is our solution. So here we go. Question number 8, and its D part. It says state one change that can be made to the transformer shown in the figure 8.1 so that it can be used as a step-up transformer. You know, in the step-up transformer, the number of the turns on the secondary coil are more as compared to the number of turns in the primary coil. That is a step-up transformer. So if you want to convert this into a step-up transformer, you have to increase the number of turns in the secondary coil, or you can say you have to reduce the number of turns in the primary coils, so that the main purpose is that the number of turns in the secondary coil must be more than the number of the turns in the primary coil, and then it will be a step-up transformer. The number of the turns in the secondary coil must be more than the number of the turns in the primary coil. Oh, I written this one, sir. Okay, so we are going to the next question. That is question number 9. A radioactive source emits alpha particles, beta particles, and gamma radiations. State A, first part is state which type of radiation produces the strongest ionizing effect. The strongest ionizing effect is produced by the alpha particles due to their larger size, their larger mass, and their larger charge. Second part is state which type of radiation is deflected most by a magnetic field. The most deflected is beta particles because of their smaller size and less amount of charge on them. So our answer is beta particle, alpha particle, beta particles. Okay. So you can see the marking scheme. Our answers are right. Okay. Question number 9 is B part. Here we says figure 9.1 shows a Geiger-Müller GM tube and counter. This detects the amount of radiation. A radioactive source is placed 10 centimeters from the GM tube. In the figure 9.2, a piece of metal 5 millimeter thick is placed between the source and the GM tube. The reading on the counter have been corrected for background radiation and shows the count rate due to the source. So when the radioactive source is 10 centimeter from the GM tube, the reading shown is 800. And when there is a 5 millimeter thick metal placed between the radioactive source and the GM tube, the reading shown on the counter is 200. So you see, when you have placed a metal 5 millimeter thick between the source and the GM tube, the reading has not has dropped from the 800 to 200, but it has not come to zero. He says, explain how the readings show that the source emits beta particles and gamma radiation. You see, the radiation is able to reach, it is able to travel 10 centimeter from the radioactive source to the GM tube. That means that here we have beta particles or gamma rays. From here, we conclude that there are either the beta particles or the gamma rays or both of them. Then when you placed a 5 millimeter thick metal piece between the source and the detector, you see the reading has dropped from 800 to 200. So because the beta particles cannot travel, they cannot penetrate through the 5 millimeter thick metal. So that means that that source was emitting beta particles, because when you put the the reading was 800, now it has dropped to 200. So that means there were beta particles because they have been stopped by that metal strip. And still the reading is 200. Still the reading is 200. That means there is something which is able to penetrate through the 5 millimeter thick metal sheet. And you know what is that? That is gamma rays. So this shows that the gamma ray is also there, because some of the radiation is still able to penetrate through this 5 millimeter thick sheet. So let me read my answer. I have written this answer. Radiation can travel 10 centimeter and reach the GM tube. This shows that there are beta particles or gamma rays. When 5 millimeter thick metal sheet is placed between radioactive source and the GM tube, reading drops from 800 to 200, which means it has beta particles because they cannot penetrate through 5 millimeter metal sheet. 200 reading means it also has gamma rays because they can penetrate through metal of 5 millimeter thickness, 5 millimeter thick metal sheet. So this is my answer. You can write, I hope, a better answer, but basic idea is this. So the marking scheme, so this is the marking scheme for this and this. You can take your time and you can read this marking scheme. Uh, so this is my answer, sir. And here we go. He says, state why the readings cannot be used to show that the source emits alpha particles. You know, you have placed the GM tube 10 centimeter from that radioactive source, and the penetration power of the alpha particles is only is less than 5 centimeter in the air. So even if the source is emitting alpha particles, you have placed the GM tube at 10 centimeter. So due to the less penetrating power of the alpha particles, they will not be able to reach the GM tube. So you cannot use this distance, this uh, arrangement to find the alpha particle. For detection of the alpha particles, distance between the radioactive source and the GM tube must be less than 5 centimeter, because the penetration power of the alpha particle is less than 5 centimeter in the air. You have placed the GM tube at 10 centimeter. So even if they are being emitted, they will not be able to reach the GM tube. So this is the marking scheme. I hope you understand. Okay, then we have, he says, describe, this is the C part of question number 9. He says, describe one way that a radioactive source is moved safely in a school laboratory. If you want to move school laboratory from one place to another place, the best thing is place the radioactive source inside a lead box and then take it from one lab to another lab, from one room to another room. So place the thing, there are other precautions also. So place the radioactive source in a lead box and then move it from one place to another. So there are so many other. I've written this one, and you can also write other things. This is my answer. Okay, so we are going to the next part. The next part is question number 10, and this is from the topic space physics. This is the new topic which is added into our content of the syllabus Physics 5054. A part, astronomical distances are measured in light years. The first portion of the question, A part is, state what is meant by a light year. You know, the light year means when the light is traveling in the vacuum, the distance traveled by the light in vacuum in 1 year is called 1 light year. So my answer is, in vacuum, the distance traveled by light in 1 year is called 1 light year. So 1 light year is basically the unit of distance. Okay. So the marking scheme is showing up on your screen. This is my answer. He says question number 10 and his second part, the sun is one star in the Milky Way galaxy. State the approximate diameter of the Milky Way galaxy. So it's a fact, it's a number which you have to remember. The diameter of the Milky Way is 100,000 light years. 100,000 light years. It's a number. Just remember that. It's a fact. You should not forget it. 100,000 light years. 100,000 light years. Okay, then he says there are several stages in the life cycle of a star. Complete the figure 10.1 to show the stages of a massive star. So we are talking about not a small star like our sun. We are talking about a massive star. Goes through after it has used up most of the hydrogen at the center of the star. Use the words from the following list. So the nebula, neutron star, protostar, red giant, supernova, and white dwarf. Okay. So we have a massive star much larger than our sun. Then it goes from so it becomes red supergiant, and then what happens? Then this happens, supernova. After supernova, it converts into a nebula, and from nebula, it converts into either a neutron star or it becomes a black hole. This is the life cycle of a massive star. If a star is too large, then at the end it converts into a black hole. And if it's just a massive star, then it converts at the end into a neutron star. So here we have, first of all, you have massive star, then it converts into the red supergiant, then the supernova happens, then nebula, and after nebula, either it becomes a black hole or it becomes a neutron star. So I hope you understand. Okay. Then we have state the stage in the life cycle of a star where very heavy elements are formed. So very heavy elements are formed in the supernova, and in the supernova, the heavy elements they fuse into each other and they form heavier elements like iron is produced. Okay, question number 10 and its C part. He says, current scientific understanding is that the universe began 14 billion years ago in an event known as the Big Bang. Explain one observation that supports the Big Bang theory. You see, um, if a source is giving out waves and it is going away from the observer, then the waves which are reaching the observer, as the source which is producing the waves is going away from the observer, its waves which are reaching the observer, their frequency gradually decreases. The wavelength of those waves increases. We learn in the Doppler effect. And you see what is happening when we observe the light which is coming from other stars and other galaxies. The light which is coming from the other stars and the galaxies, when we observe that light, their light has a larger wavelength than the normal light. So, and their frequency is less. This is called red shift. So when we observe the faraway galaxies, faraway stars, all of them, the light coming from them, that shows that the light which is reaching the earth from them has larger wavelength and less frequency than the other light which is coming from our sun. So from there we say that these light rays are showing redshift. So we observe this. This is called the redshift. So from there we have concluded that those stars, those galaxies are going away from the earth. The stars which are more away from the Earth, they have more redshift. The galaxies which are more away from the Milky Way, they show more. The galaxy which is little nearer show less redshift, and the galaxy which is further away, that shows more redshift. So it means that all the stars and the galaxies, they are moving away from us. So from observing their from observing the wavelength and the frequency of the light which is coming from those stars and those galaxies, we are able to tell that how far they are away and at what speed they are going away. So if in time we reverse that process, if those things are going away, if we reverse them, then we get an idea that at some time in the past, like billions of years, like 14 billion years ago, these things were one. And some explosion took place. We don't know why, but something happened. An explosion happened, and it exploded, and now they are going away from each other. So that explosion happened like 14 billion years ago. That is called Big Bang. Woo, I hope you understand. This is the new topic which is added into the Cambridge syllabus. So I have tried to write this. Also, let me, okay. The light from the other stars show redshift. This is our observation. Other stars and galaxies. So the explanation is the light coming from the other stars and galaxies have less frequency and longer wavelength. This is called redshift. Further the star or galaxy, more its light shows redshift. This means that the stars and the galaxies are moving away from each other. Further the star, more is its speed with which it is going away. This we have observed we have concluded from the amount of redshift. If we reverse this phenomena, all the universe was together billions of like 14 billion years ago. Some explosion happened, and the universe, stars, and the galaxies started moving away from each other. This explosion is called the Big Bang, and this is the evidence. Uh, so we can read this. Okay. Okay. So one mark is for saying that the redshift increases in the observed wavelength, reduction in the frequency mentioned, or galaxies, stars moving away from the Earth, separating. Further, this is one mark. The other mark is for saying that the further away the galaxy star, the greater is its speed, greater redshift, greater increase in the wavelength. Another mark is for saying going backwards in time at start, stars or galaxies were close together or high density or very dense. Another number is for saying cosmic microwaves background mentioned or universe expands. And one mark can be also for saying remnant heat radiation, leftover radiation from early universe observed. Radiation has redshift, longer wavelength, smaller frequency, becomes cooler, or CMBR is uniform observed in all directions. So this is the market. We have written this answer, this 3 marks answer. Okay. We have not written about the radiations. Let me reduce the size so you can see the whole answer. This is my answer, sir. And it's approximately 4 marks question, 3 marks for the explanation, 1 mark for the observation. So I think we have reached the end of this paper. So my dear students, today in this video, I have presented you the solution of this paper. This is 505422 May, June 2023. This is Cambridge O-Levels Physics. So I have tried my best to write the answers and check them with the marking scheme. And I have also tried to explain you the concepts. If you think that this video is useful for you, if you think that this video is helpful to you, please share the link of this video with your friends, with your class fellows, with your teachers, with your junior students, with your cousins who are studying O levels. Also share the link of this video onto your Facebook, onto your Instagram, onto your Twitter, onto your X, onto your TikTok. So whatever social media you are using. Because you see, when you do this, this helps me to promote my channel and I will be able to continue this work. And it's a great blessing for me that I can do this and I can make videos which touch the life of so many students around the globe who can study and who can practice past paper practice by sitting at their home and watching YouTube videos. So it's a great blessing for me. Thank you very much. Have a good day. God bless you all.